What up? What up? Anyone on here yet? Happy Friday, everyone. I'm kind of excited for today. Not going to be integrals. I feel like we're a little tired from those. What do you guys think? So we're definitely going to do just areas under the curve. I'm making up for yesterday's trolling. I was definitely messing with all you guys when we were doing some integrals. Shout out Kit. But yeah, we're going to do some basic areas under the curve. I'm going to start off with some, a small proof as to why the area of a triangle can be used or can be solved by integrals. And then we're just going to get to areas under the curve. Maybe if we have time, we can definitely do some disk method, some washer method. No shell today. Okay. So let's just get started. If you guys want to hop on by, we'll love to know what everyone's weekend's plans are. Some kids didn't have school today. Some maybe took the day off. Monday, no school, no work. Let's go. All right. I think I got everything set on my end. If you guys can't hear me or anything, let me know. All right. So the very first thing that I want to kind of start talking about is what happens when I have an equilateral triangle. I know it looks a little messy. And I have 12, 12, and I have 12. Now, because this is equilateral, all the degrees are going to be 60. Let's make this a little nicer. Hopefully everyone can see that. All right, so what happens when I have a triangle that looks like this? I want to find the area. Does anyone know how to find the area of this? There's a specific equation for it. There's many ways of doing this. My favorite is just using area is equal to 1/2 AB sine of C. So if I do that, that's going to be 1/2 12 times 12 times sine of 60. All right, so let's talk about that. I feel like I need to make sure I have my graphing calculator on here. Not that I need to multiply 12 times 12. I know what that is. But pretty soon, things are going to get more difficult. So I got to make sure everything's charged and ready to go. Okay, so 12 times 12 is 144 divided by 2. That's going to be 72. And then times sine of 60 is going to be 1/2. So this area, the area of this whole thing, is going to be 36. Okay. Now, bear with me. I'm doing that for a reason because now I'm going to go ahead and use calculus for this, okay? I'm going to graph this on an X and Y plane, and I'm going to show you how we can find the integral, how we can find the area underneath the curve to show that this area is 36. So don't forget, we know that the area of this triangle is going to be 36. Let me erase this and make it a little smaller. If you guys have been on my lives lately, you already know that we're making things smaller here. We know how to do that. Okay, so just keep this in mind, okay? The area of this is 36. If you can't see it, let me know, and I'll definitely comment, and I'll let you know what this value is. All right, so let's go ahead and draw the X and Y plane. Maybe I can draw some straighter lines. Okay, and then here is my triangle. So let's do it in blue. This one and this one. And we're going to draw it on here. Ha, shit. I cannot believe I already started with that. You're absolutely right. Sine of 6 is going to be 30, root 3 over 2. My bad. Okay, but this is good. So we're going to go ahead and talk about that. Let me go ahead and fix that real quick. So area is equal to 1/2, 12 times 12. And then sine of 60 is root 3 over 2. I cannot believe I just talked about knowing the unit circle, and I'm forgetting it for whatever reason. It's Friday, guys, all right? Be nice to me. All right, so this is going to be 72 times root 3 over 2. So just a little different. The area should be 36 over root 3. So we're going to show how we're going to prove that using the unit circle or some integrals, okay? So let's go back to our X and Y plane. This is going to be 12. If I cut this in half, this is going to be 6. This is going to be 6. That's going to be 12 because, again, don't forget, Anita, I have no idea what you're saying. Don't speak French, so sorry. So when we have this, I cut this in half. So who can tell me what the height is going to be? We already know this is an equilateral triangle. This is an equilateral triangle. Who can tell me what that height is going to be? I could definitely use SOHCAHTOA. but I'm going to use a special right triangle, okay? So automatically, I'm just going to tell you right now that this height is going to be 6 root 3. Okay, now why am I doing this, all right? So now we're talking about finding the area using calculus, using the area underneath the curve. I'm going to find the equation of this blue line that I'm graphing here. Okay, let me make it a little bigger now. So I'm talking about this blue line that I just highlighted. Okay, so we're going to find the equation of this function. Now this function looks like it has a y-intercept of 0. It's a linear equation. So we're just going to find the slope, and that's the rise over the run. And that happens to be the rise is 6 over 3 over the run, which is 6x. So if I simplify this, this is just root 3x. All right. So then all we have to do is find the area underneath the curve of this function, root 3x. Now we just got to find the parameters. Well, let me draw these in red. In the beginning, it starts at 0. And now it goes to this end over here, and that's going to be just 6. So our parameters are from 0 to 6. So now let's go ahead and use some calculus skills and solve for this. We're going to go ahead and use the first fundamental theorem of calculus. So we're going to use the power rule for that root 3 over x. And this is going to be root 3x squared over 2 from 0 to 6. All I have to do now is plug in the 6. And we get root 3 times 0 squared, times 6 squared, I'm sorry. Let me erase that. 6 squared over 2 plus root 3, and then I'm plugging in the 0. 0 squared over 2. Whoops, that looks like a 6. I'm just make that a 0. Awesome. So if I simplify this, this is root 3 times 36 over 2, or this is just 18 root 3. Now, if you notice, I only found the area of half of the triangle, which is this one. I'm going to color it in yellow. I only found half of the triangle. So all I have to do now is multiply it by 2, and guess what? I get that the area of this whole thing, when I multiply it by 2, we already know it's 2 times 18 root 3. Oh, snap. Look at this. 36 root 3, which is the exact same area that we found when we were doing 1/2 AB sine of C. And thank you to Math Nerd for correcting me that sine of 60 is root 3 over 2, because otherwise I would have gotten a different answer here, and I would have been completely confused. Okay, so that was a good starting point. I just kind of wanted to introduce how we can use geometry, some algebra 2 skills, some trig skills, I would say, and how you can implement some calculus into it. All right, so I think now we can definitely get into some more calculus-based material and talk about how we're going to find the area underneath the curve. All right, guys, what's everyone up to today? What is going on? I know it's Friday. Anyone have some weekend plans? Some people have a 4-day week or a 4-day weekend. That's kind of exciting. Whoops. Yeah, let's just do 1/2 x squared. Okay, you're going to see that I'm labeling these equations for a reason. And then I have x is equal to 1, and I have 4x is equal to 3. So they're going to want us to find the area of this bounded, the area that's bounded by these curves. You know, important pre-calc skill, you don't necessarily need to know that equation that I wrote, 1/2 AB sine of C, but you should definitely, just practice. I think it's always good to revisit all the material that you learned, because calculus is just that. Calculus is very easy, but it's the materials that you learned previously or in the previous years that makes it more difficult, in my opinion. I had to get a LaCroix on here. All right, guys, so let me just go ahead and graph this real quick, and you're going to tell me which graphs are which. So there we go. I have my labeling. So it looks like I have a function that, whoops, didn't mean to erase that. I have one parabola, and I have another parabola. And the way I'm graphing these, I know how the graphs look, so I'm doing that for a reason. Okay, and then I have one. And then I have another one. So this is x is equal to 1, and then I'm just going to show you the other line. So this is x is equal to 3. Okay, so they want us to find the area bounded by these curves. Okay, so we're going to take the area of this, and because we're using calculus, we need to find the area of this. I like to call this rectangle, or some people call it the radius, or this region here. If we can find that, we can go ahead and set up our integral correctly. But the first thing that we need to find is, what is the equation of the graph that I just highlighted in blue? Do you guys think it's equation number 1, or do you think it's equation number 2? Let me know in the comments below what you think. Equation number 1 or equation number 2? All right, so it doesn't seem like much people know, but that's okay. Oh, I see. Ashton said 2. Hamchi said 1. User Cerna said 1. It's actually going to be equation 1. Why is that? You can kind of look. Yes, look for the y-intercept. Math Nerd said the y-intercept is 10. So in equation 1, that's the y-intercept 10. So the graph, or the blue function, is going to have a y-intercept of 10 if I continue graphing it towards the y-axis. So we know that this is going to be the equation y equals 2x squared minus 8x plus 10. And that leaves us with the equation, the parabola that we have on the bottom, which I highlighted in red. What equation would that be? So it's only going to be, we only have one other option. That's going to be the quadratic. Can anyone tell me another reason why that was the bottom equation? I'm looking for maybe like the stretch or the compression of this. So this one has a, you can call it a vertical compression. Some people call it a horizontal stretch. It's many different ways of describing it. But because the coefficient is 1/2 in front of the x squared, it's going to be a little wider. Okay, so that's how you can kind of see how this works. Oh, nice. So Math Nerd said, okay, you can look for the vertex. That's absolutely true. It's really cool. Guys, whatever you feel you can justify to say this is your answer, that is always good. So always practice that. So Math Nerd said, if you complete the square, you can find the vertex, and that is 100% correct. Okay, so now we're just going to go ahead and set up our integral. We're going to find the integral of the top function minus the bottom function. And we already established which one that is, so that's the blue function. So that's 2x squared minus 8x plus 10 minus the red function. And that's going to be 1/2 x squared minus 2x minus 1. And then I have dx. But who can tell me what my parameters are going to be? Because I need to take the area underneath the curve. It needs to have some parameters. What do you guys think? What are the parameters? Anthony, 1 and 3, I 100% agree. Yes, it's going to be 1 and 3. Why is that? Let's look at the graph, okay? Not only did they give us the x values in 3 and 4, but when I graph it, you can tell that it's going to be 1 and 3. All right, so let's go ahead and simplify this. This is a very basic integral, I would say. All we have to do now is go ahead and distribute the negative sign to that second fraction, or that second parentheses. And now we're going to have integral from 1 to 3 of 2x squared minus 8x plus 10 minus 1/2 x squared plus 2x minus or plus 1. Okay, should we start integrating now, or should we do something else? What does the chat think? One thing that I'm definitely going to do is try to combine some like terms. Yes, unknown. Thank you. Like terms. So let's see. I have 2x squared and I have a minus 1/2 x squared. So that's going to be still integral from 1/3 of 3/2 x squared. Part about calculus is you got to know how to subtract some fractions. I know a lot of people hate fractions in middle school and high school, but gosh, you have to know your fractions. I cannot stress that enough. Okay, let's go back to this. Let's continue. It looks like we can combine negative 8x and the positive 2x. And that's negative 6x. And then the last thing that we have to combine is the 10 and the plus 1. Notice how I gave these different shapes so I can just keep track of what I'm combining, just in case, I want to look back at my steps. So now it's plus 11 dx. All right, so let's go ahead and create some space on this blackboard here. I'm reading some comments. Someone said divide the left by 2. We can, or maybe factor out a 1/2. I mean, there's so many things that we can do here. But let's just continue. Okay, so now I'm going to go ahead and implement the first fundamental theorem of calculus, and that's taking the integral of this. So that's 3/2 x cubed over 3 minus 6x squared over 2 plus 11x. And then this is from 1 to 3. Okay, and guys, I am showing all the work in the next few problems. I'm definitely going to want to just kind of like breeze through some of these when it comes to the fractions and stuff. But for now, just try to, if you have any questions, let me know, and then I'll try to explain it. Okay, so inside this bracket, I can cancel out the 3. The 6 and the 2 will become a 3. And then there's nothing that I can do to the 11. All right, so then now we have x cubed over 2 minus 3x squared plus 11x. And then that's from 1 to 3. Okay, if you recall first fundamental theorem of calculus, we're going to go ahead and implement the 3. Plug everything in. So that's 27 over 2 minus 3 times 3 squared, which is 27. You know what? Squared, I'm just going to put 27 there. Plus 33, and then minus, I'm going to go ahead and plug in the 1 into everything. And that's 1/3 minus 3 plus 11. All right, so let's go ahead and combine these things. This is the thing about calculus. It's kind of annoying because you have to know some fractions. You have to be very careful when you're combining these things, but it just takes some time, and honestly, it's not as difficult. You just have to be patient with it. Okay, so I got 27 over 2 minus, I guess, or I can put a plus 6 if I combine the negative 27 and the 33. And then I'm going to distribute the negative sign in the other values. So minus 1/3, and I could do minus 8. Okay, let's continue combining these things. If I combine the 6 and the 4, or the 6 and the negative 4, that's negative 2 plus 27 over 2 minus 1/3. All right, for the sake of time, I'm only doing this because I want to continue doing more problems, but I'm just going to plug this into the TI-80, my TI-84 calculator, which is really nice because it simplifies everything into a fraction. And I get that the area between these two curves is 67 over 6. That's it. That's it, guys. All right. So let's go ahead and do another one that I'd say can be a little difficult. Let's go ahead and try this one. Someone says, should the 1/3 be a 1/2? I believe, oh, that's where I got that. Yes. Okay. Thank you for catching that. I'm like thinking of all these different things. I'm making sure that the screen's looking okay, and I'm making sure that the everything's up and running. So I kind of make some mistakes. So yes, this should be a 1/2, which will be a 1/2 here. We should be a 1/2 here, and then that would mean that I am, the answer is going to be 11, not even 66. I was going to be 1/6 off because the answer was 66 over 6 or just 11. All right. Thank you for that, math nerd. You the man or you the woman. I don't know. Awesome. All right, guys. Let's go ahead and try to do another one, and this one's going to be tricky. Yes. Let's do this one. Okay, so I have first equation is a negative x cubed over 2 plus 2x squared, and then 2. This is y is equal to negative x squared plus 4x. Nice, non-binary. Respect, shout out. All right, guys. So let's go ahead and just graph this equation, and you can tell me which one is which. You're probably going to tell right away, but it looks like I have an equation that looks like this. And then I have another equation. Actually, let's go ahead and draw this one in green. It's going to look like this, and then it goes like this. Okay. So I have two areas now. I have this area in red, and I have the area in blue that I need to take care of. All right, so who can tell me which equation is going to be the one in yellow? Is it equation 1 or equation 2? One of them is a cubic, one of them is a quadratic. Nice. So yes, equation 2, absolutely. So now we have equation 2 is going to be the one in yellow. So this is y is equal to negative x squared plus 4x, and it leaves us with the green one being negative x cubed over 2 plus 2x squared. Okay, so this is where we have to be very careful, okay? We have two different areas. One of them, the one in green, if you notice, the top function minus the bottom is different than the area in blue. The top function minus the bottom function is just a little different, okay? But what we need to do here is we need to find where these points intersect, okay? Let's not worry about that today, but I will tell you that they intersect at x is equal to 2, and then they have an x-intercept at x is equal to 4. We'll talk about how to do that later on because it could involve rational root theorem, all that stuff. Don't want to do that today. All right, so let's go ahead and talk about just the red area. So let's call that area 1. Okay, so top function, which is the one in yellow, so negative x squared plus 4x, minus the bottom function, which is negative x cubed over 2 plus 2x squared dx. All right, who can tell me the parameters? This is area 1. Zero to 2. 100%, 0 to 2. All right, so I'm going to go ahead and combine these real quick. And don't forget that in that second value, because we're subtracting, we need to distribute that negative sign. So we have negative x squared plus 4x plus x cubed over 2 minus 2x squared dx. All right. So we need to combine the like terms. It looks like the only thing that we can combine are the x squareds. So that leaves me with this beautiful integral 0 to 2 x cubed over 2 minus 3x squared plus 4x dx. All right. As always, guys, if you've seen or if you've been in my lives a couple times, you know we always need to create space on here because we're always writing these scribbles and we always need to simplify these things. Okay. I just want to tell you next week, I believe Tuesday, it's going to be another integration bee. So I'm going to pull out some other integrals. If you were here yesterday I was trolling you guys a little bit, but I'm going to make sure that I give you guys some stuff, and I won't mess with you guys this time. I'll make sure that I'll give you problems that we can all do together. Okay. So let's continue with this. Did I combine this? Yes, I did. All right. So now let's go ahead and use the first fundamental theorem, power rule. You guys already know the drill. This is x to the 4th over 8 minus x cubed plus 2x squared, 0 to 2. All right, curious if you guys knew or if you know exactly how I did that. Give me a thumbs up if you understood how I simplified that right away. Remember I mentioned the first integral, I just kind of went with it and I showed every single step, but this time I'm just going to simplify it as we go on the fly. Awesome. Yes. Got to know your fractions. All right. Okay. Math nerd, let's go. And queer Harry, yes. Harry, let's go. Awesome. Okay. So now let's go ahead and combine or plug in the two. And math nerd is going to make sure that I'm plugging in these things correctly. So this is going to be 2 to the 4th power. That's going to be 16 over 8 minus 8 plus 2 times 4, which is going to be 8. Minus, and now I'm going to plug in the 0 into everything. And what do you know? That's just a big fat 0. Cancel that out. Awesome. Okay, if you look in that first parentheses, the 8 and the 8 cancel out. So the only area that we really care about, area 1, is going to be 16 over 8. Okay, before I even make this smaller, let's just go ahead and set up our second area. So remember, this is just a little different. This is now the top equation, which is the cubic one. So this is negative x cubed over 2 plus 2x squared minus the bottom function, which is a quadratic, negative x squared plus 4x. And what are the parameters for this one? Who can tell me the parameters? Two to four. Let's go, man. We got some smart people on here. I love it. Okay, so as always, we're making this smaller. Oh, one day I can't wait to just shrink it. I wonder how many levels of small we can make this. That'd be really cool. Okay, so that's area 2. So let me just go ahead and rewrite this. Area 2 was equal to the integral from 2 to 4 of negative x cubed plus 2 plus 2x squared. And then now let's just go ahead and distribute that negative sign that we had set into the second parentheses. And we have plus x squared minus 4x dx. Okay, let's go ahead and combine the like terms. By the way, I'm curious, everyone in the chat, what is everyone covering? Is it calculus? Is it multivariable calculus? Are you guys just in algebra 2, pre-calc? I'm trying to gauge what we should continue covering. This calculus stuff is always fun, but I love to know what everyone else is doing. Okay, have that x squared. I'm going to go ahead and combine that. Looks like that's the only thing. 2 to 4, I'm sorry. Negative x cubed over 2 plus 3x squared this time minus 4x. Calc BC, differential geometry. Nice. Complex analysis. Wow, I haven't taken that in such a long time. Associate to Math BA and Chem. Ooh, let's go. Calc 2 next. Nice. Oh, you guys are in for a fun ride. I'm so jealous. Honestly, like seeing these things for the first time, I mean, so fun. Amazing. When I was in college, I had 5 math classes in one semester, and it was probably the best time of my life. Nice. Calc 2 review. Stochastic calculus. Okay, you're gonna have to explain that because I have no clue what that is. Anyway, all right. So first fundamental theorem: negative x to the 4th over 8 plus x cubed minus 2x squared. I saw a couple thumbs up before, and I'm hoping that everyone understands how we just simplified that right away. All right, and now we're gonna go ahead and plug in the 4 in here. Ooh, things are gonna get crazy. So let's see. For the first one, when I plug in that 4, it's going to be, negative 256 over 8. And I think we can simplify that already, right? Negative 32. So let's just do that now. So this is negative 32 plus 64, because that's the 4 cubed, minus 2 times 4 squared, which is 16. So minus 32. Okay, minus... And this time we don't have a big fat 0, so we have to plug in the 2 into everything. Cerebral Barrett, let's go. Yes. Triple integrals of Feynman technique. I will do that soon, okay? That's probably going to be more for like Tuesday or Thursday when we get crazy. Today I want to keep it consistent. I don't want to go off the rails because the last two lives I did were just crazy. Yeah, we'll talk about that later. Okay, so when I plug in the negative or the 2, this is negative 16 over 8. So negative 2 plus 8 minus, and then I have 2 times another 4, so minus 8. Okay, so in that first parentheses, the 32s, whoops, don't cancel out. The 32s, the negative 32 and the negative 32 become negative 64 plus 64. That cancels out. That's really nice. And then I'm left with negative, and inside the parentheses, the 8s cancel out. So I'm left with negative 2. And then this is the area for this is 2. And then don't forget, the total area was the sum of both. So we had area 1, which was 16 over 3, plus the 2. Let's just get common denominators on that. 22 over 3. That is our area. Yeah, we'll do some Feynman techniques for sure. Was it 16 over 8? I think I erased it. Are you oh, yes, you're right. I see it now. It was 16 over 8. I erased. Zoom does this weird thing where, like, when I erase things, it goes away. Thank you, Math Nerd. Bro, Math Nerd, dude, or Dudette, you got to email me. I'm going to send you a free book because you're keeping me on track, and I'm just loving it. Thank you. Thank you so much. So let's change this real quick. It wasn't 16 over 3. It was 16 over 8. I need someone on here. Math Nerd and I'm going to say Queer Harry, like the honorary moderators today. They are making sure everything is on track. So 16 over 8 plus 16 over 8, which is pretty sick. Wait, was this? Oh, shit. So it was both 2. Okay, so then the answer is just 4. Can't believe I didn't think of those fractions. 16 over 8 is going to be 4. All right. This is pretty sick. All right, so let's go ahead and do another one. So far, I've been telling you when the functions are equal to each other or like where they intersect. Let's do one where we actually have to find it. So we're going to do the area bounded by 2 curves again, and then we're going to find where they intersect. Okay. All these are pretty simple. You could definitely major in math if you want to. Stats I think is applicable, but you know what? It's guys, if you're thinking about pursuing a career in math, you should definitely think about the future and to what that entails, in the job force. A lot of people, for example, my dad, when he was an engineer, he was a computer programmer, or he still is. He was emphasizing that I got to get into STEM, I got to be an engineer, and I personally did not like that. So whatever you guys feel like doing, try to pursue it. You got to have fun. Okay, so if you're an engineer and if you're taking these classes and if it's not fun, then what's the point? Because then you're going to have a career and you're going to be hating your life for the next 40, 50 years, however long we want to live. So one thing I would say is have fun with it. Do what you think is best. I love math. I pursued it. I never wanted to be a teacher. I didn't want to work for a school district, and now I run my own business. I'm a private tutor. I do what I want, and I do this for fun. So I have the time to do this. I personally like it. It's now made me, I'm making money off it now, which is really nice. But you got to think about what you want. All right. At the end, you got to have fun, and at the same time, you got to think of what your future is going to entail. Anyway, here we go. We have 2 functions. Function 1 is going to be x minus 1 cubed, and then function 2 is going to equal to x minus 1. Okay. Sort of nice, I would say. Okay, so here is the first function. It's a straight line. And then here is the other function. Whoops, I'm not even going to do that. Maybe I should make it a little bigger and make it in blue. Okay, you guys can probably guess where these functions intersect, but we need to find where these functions are equal to each other, okay? Because we have 2 different areas. We have an area that's in yellow, and then we're going to have an area that is in red. Okay, so how do we find where these functions are equal to each other? What are we supposed to do? What do you guys think? Austin says set the equal to each other. Yes, set them equal to each other. So let's go ahead and do that now. So I have x minus 1 cubed is equal to x minus 1. All right, what do you guys suggest? Should I expand that whole thing? I feel like I need to, right? Or do you guys have another idea? Do you guys have an idea of what this value is or when it intersects? I could do a few things here, okay? But I'm just going to distribute it. Let's just say we couldn't find the solution. Okay, so Mathner said let's subtract the x minus 1 and take out a common denominator. Okay, 0 is obviously an answer. Divide by 0. Oh, okay. So here's the thing. We could divide by x minus 1, but that is a huge issue because we have a variable. If you divide it by x minus 1, it's probably you're getting rid of a solution by doing that, or you run into some complications. I will always suggest when we're trying to solve for variables, don't try to divide by that one variable. But let's go ahead and try this out. Okay, let's go ahead and bring out the x minus 1 to the other side. I was hoping that someone can give us pointers. I didn't want to foil this entire thing out, but check this out, guys. I just subtracted the x minus 1 to the other side. Okay, John White Sox. I'll look at that in a second, okay? And check this out. Because they have, if you notice, they both have a common value. They have an x minus 1. So I'm going to factor that out, and I'm left with x minus 1 squared minus 1 is equal to 0. Look at that. And so now we use the zero product property, okay? So when we have two things being multiplied to each other and it equals to 0, either both of them are equal to each other or one of them. So we're going to say x minus 1 is equal to 0. That gives us one answer. That's x is equal to 1. So we know, that's one of the points where the functions intersect. And then the other one is going to be x minus 1 squared minus 1 is equal to 0. Okay, we can do a few things here. I'm just going to move the 1 to the other side and then complete the square, or not complete the square. Fuck that. I'm going to take the square root. X minus 1 is equal to plus or minus 1. When you take the square root of both sides, do not forget to add the plus or minus 1. Fuzzy balls, yes, I definitely want to do solids. We're probably going to do that for maybe next week. Okay, next week I have a fun schedule plan. We're going to do Tuesday, integration B. Thursday, I guess we can do solids or revolution. And then Friday, we're going to do like a poll thing, or maybe I'm going to do a giveaway or something like that. But we'll figure it out. Anyway, so back to this. If I add the 1 to the other side, I get x is equal to 1 plus or minus 1. And so now I have two answers. X is equal to 2 or 0. All right, so looking at the graph before I make this small, it looks like we have the x is equal to 0. We have the x is equal to 1, and then we have where they equal to 2 here. Let's go. Okay, so we found where they equal to each other. I definitely gave an easier one. So let's go ahead and create some space on the blackboard here. I call it a blackboard, but it's technically like a green. I don't even want to say it's a green board or something like that, but whatever. All right, guys. So like we mentioned, we have two integrals. The first one is the area 1, which is the integral from the top function and to the bottom function. So integral of the top function, that's the cubic one. So this is x minus 1 cubed minus the green function, which is the linear one. All right, who can tell me the parameters here? Zero to 1, yes. It's going to be from 0 to 1. All right. Now, here's the cool part about this. I am not about to multiply this entire thing out. So what I'm going to do is Austin, thank you, 0 to 1. So what I'm going to do is I'm going to do u substitution. U is equal to x minus 1. Du is equal to dx. And now I'm going to have a new integral. I'm going to have u cubed minus u du, but my parameters are going to change, okay? Because now we're in the u universe, okay? Now we're integrating in terms of u. So what we're going to do is we're going to change it. So when x was equal to 0, we're going to utilize this value for u that we found. That means that u is equal to 0 minus 1, so negative 1. And when x was equal to 1, that means that u was equal to 1 minus 1, which is 0. So look at my parameters that I'm about to put on that integral that we found. It's going to be from negative 1 to 0. Okay, give me a thumbs up if you guys agree, or if you understood how I got that. Or like this video, do whatever you want, go crazy. Actually, I can't even tell if people are like, okay, cool, I see a thumbs up, math nerd. My mods, basically, these people are holding me accountable. Queen Harry, a math nerd. And then we got Austin over here with the abacus. Let's go. All right, guys. So we are going to do the integral here. Pretty simple, I would say, because now you just use the first fundamental theorem of calculus. So that's u to the 4th over 4. Whoops. Let me make this u to the 4 over 4 minus u squared over 2 from negative 1 to 0. When I plug in the 0, that's just a big fat 0. Area between polar curves. Okay, I would definitely try to do that. Again, I'm trying to stick on the rails, but I'm going to take a note of it. That's definitely what I want to do. Okay? And then negative 1 is going to be 1/4 minus 1/2. And if you know your fractions, this is negative 1/4. And so this is just going to be 1/4. So that's area 1, guys. Now we got to find area 2. So let's go ahead and do that real quick. How much time we got? Ooh, I got some time. Let's go. Wait, I kind of lied. I don't have that much time. I do have to go soon. Oh, shoot. Okay, sorry, guys. See, this is what happens. I erase things on accident, and then the whole screen erases. All right, here we go. So we're going to do area 2. This is going to be the integral of the top function, which is kind of small to see, but this is the linear function. So this is x minus 1 minus the cubic function, so x minus 1 cubed dx. Okay, who can tell me the parameters for this one? I believe we found it already. Harry, thank you for the gifted. Yes, I agree. Math nerd, keep that a secret. Yeah, because I definitely drew it a little different. Yeah, so everyone's saying area from 1 to 2. That is 100% correct. So let's go ahead and do that. Okay, so from area from 1 to 2. And we're just going to use u substitution again. U is equal to x minus 1. Du is equal to dx. All right, so let's go ahead and try this exercise. When x, actually before I even continue, let's go ahead and do, can you guys see that? Yes. So we're going to do area or integral. There you go. Integral of u minus u cubed du. Okay, so let's talk about the parameters. Okay, so now we want the parameters in terms of u. So if x is equal to 1, so we said y is equal to 0. And if x is equal to 2, who can tell me what the u value should be? It is going to be 1. It is going to be 1. All right, so let's go ahead and set up this integral or continue setting this up. This is from 0 to 1. So now we have u squared. Whoops, when I take the integral. There you go. Okay, so we said 0 to 1. So I have the u squared over 2 minus u to the 4th over 4. 0 to 1. Let's plug in the 1. That's just 1/2 minus 1/4 minus, when you plug in the 0, that's a big fat 0. Awesome. So the area is going to be 1/4. And just like Mathner had said that these functions, the area 1 and the area 2 were literally just the same functions. I think they were just inverted, but they both have the same area. We have 1/4 and 1/4. So our total area is 1/2. Let's go. 1/2. Awesome. Oh man, these are so fun. Okay, so I'm going to try to find another one that makes it a little trickier, I would say. Oh, snap. Okay. I have not done this one, but I'm curious as to how we would solve it. Okay, so let's see. I have function 1 is f of x is equal to root x plus 3. And then function 2 is g of x is equal to 1/2 x plus 3. One of the things about calculus, and honestly when you're learning higher level math, is you should have a good idea of how functions look like and what that means in terms of their transformation. Okay, so Med, not a problem. 16, nice. That was the first, I was 16, I believe, when I took my first calculus class. So fun. Welcome, man. Good luck to you. All right, so like I mentioned, you should have a good idea of how to graph these functions in terms of like how they look and how they translate. Okay, so we have the cubic function, 15 here, balls, let's go. Okay, so we have, let's talk about the root function, okay? The root function looks kind of like this. This is the original root function, but what does the plus 3 do? What do you guys think I have to do to this function? It goes up, vertical shift up. Absolutely. You're going to go up, and not just vertical shift up, but we're going to give it a specific value. It's going to go up 3. You guys already knew that. So really what this function looks like, if it starts at 3 and it kind of goes like that. Okay, so let's go ahead and erase that. All right, this next one, the second one, g of x, is a linear function. Okay, really, really simple. At this point, you should have a good concept of how you graph the y-intercept at 3, and then you go up 2 over, or up 1 over 2, up 1 over 2, and I think it goes, I actually don't know how this function graphs. John Whitebog, I will look for that that equation. Okay, I saw your comment. I'll look back at it when this finishes, and maybe I'll tag you. Yeah, who knows? Who knows? All right, guys. So let me just double check how this function looks. I don't want to steer you guys in like all these different directions. I just want to know which one is on top, which is on the bottom. Oh yeah, so I did graph it kind of correctly. So it goes like this. Okay, so maybe not the best graph, but let me just redraw it. It's going to look like this, and then we have the function that looks like that. So you're trying to find, let's not use green. Let's go ahead and do the blue area. Okay, so luckily for us, it's only one area, but again, we need to find out when these are, it took me 5 years to get the book answer. Okay, I was going to leave you a question myself, but let's just continue. Guys, I go off the rails. I read the chat all the time. Oh, man. I don't know what I do. I don't know why I do that to myself. Okay. So let's go ahead and find when these are equal to each other. I'm pretty sure we all know it's going to, they're going to intersect at x is equal to 0. We will see that soon. But again, set the equations equal to each other. So f of x is equal to g of x. And now we have root x plus 3 is equal to 1/2 x plus 3. Okay, so the 3's are going to cancel out. If I brought the 3 to the other side, they're just going to cancel out. So I'm left with root x is equal to 1/2 x. How do I solve this, guys? What should be my next step? I am out of water, out of coffee. Yes, someone said square root, square both sides. 100%. Let's go ahead and do that. All right. So then we're going to have x is equal to, well, let's go ahead and show how we're going to square. So we're just going to square both sides. On the left side, the square root goes away. And on the right side, I have 1/4 x squared. Don't forget to square that 1/4. That's where things get tricky. All right. Just because I don't like to have a coefficient in front of the x squared, I'm going to multiply the 4 to the other side. Okay, and I have 4x is equal to x squared. And every time you have a quadratic, what do you know? You should always bring everything to one side, set it equal to 0, and solve for x. All right, so I have x squared minus 4x. And I can definitely factor. I'm going to factor out an x. And then this becomes x minus 4. And again, we're going to use a zero product property, okay? So whenever you have two things being multiplied together and one of them and it equals to 0, either both are equal to 0 or at least one of them is. So that means x is equal to 0 or x minus 4 is equal to 0. So that means x is equal to 4. All right, give me a thumbs up if you guys understood how we got the 0, got the 4. Like this video, give it a little tap, gif, whatever you want to do, just so I know that you guys understood it. All right. I see a thumbs up. Let's go. Perfect. Okay. So now we know that they intersect at 0 and at 4. No surprise there that it's at 0 and then it's at 4. Okay, I just realized this is going to be our last problem. However, we're going to find the area, and then we're going to rotate this about the x-axis. We'll have some fun with that at the end, okay? All right, you guys already know the drill. Let's go ahead and make this smaller, and we're going to take the area now. Okay, so the area, looks like we only have one area that we need to worry about. So the area is equal to the integral from 0 to 4 of the top function, which is root x plus 3, minus the bottom function. Okay, notice how I like to put parentheses. It's always good to keep, Harry, yes, absolutely. It's so chill. I love it. It's just kind of fun. Okay, so we're trying to find the area of this, right? Notice that I use a parentheses. It's always good to be consistent with those so that you can pay attention to whether or not you have to distribute a negative or something like that. Okay, so let's go ahead and distribute that negative here. And that leaves me with integral from 0 to 4 of root x plus 3 minus 1/2 x minus 3 dx. Those 3's cancel out, so we're left with root x minus 1/2 x dx. Okay, Let me just kind of move this a little bit here. If I'm going to take this integral, before I do that, because I have a radical, it's going to be x to the 1/2 minus 1/2 x dx. And I'm going to implement that power rule. So x to the 3/2 and then a 2 on the top and a 3 on the bottom. That's the tricky part. Give me a thumbs up if you guys understood that one, or at least let me know if you're confused. I know I explained that in a second. Plus x squared over 4 from 0 to 4. Okay, as we do that, I'm just going to go ahead and kind of make this a little smaller. Okay, awesome. All right, so let's go ahead and plug in the 4 into everything. And that's going to leave us with 2 times x to the 3/2 over 3 plus 4 squared over 4 minus, and then that other one, when you plug in the 0, that's just a big fat 0. Someone said, isn't it minus? Yes, you're absolutely right. Oh, I was about to say, we're math nerd, where are you? Absolutely. Yes, it should be a minus x to the 4th. You're absolutely right. So let me go ahead and change that. I did have it there, but when I integrated, I guess I didn't do that. I swear to God, I feel like I'm dyslexic, or I have ADD or something, because I cannot remember those things. But costly, that would have been really bad if I forgot that minus. Okay, I think I fixed it. So I'm going to continue. When I plugged in that 0, it's just going to be a fat 0. And now I'm going to simplify this, okay? That 4 to the power of 3/2, you have to think of it as the square root of 4, which is 2, and then to the power of 3. So this is 2 times 8 over 3 minus, and then 4 squared is 16 divided by 4. That's going to be 4. Okay, so let's simplify this. 16 over 3 minus, I'm going to turn that 4 into a 12 over 3. Boom, guys. We found our answer. 4/3. Yes, I'm about to do volume, okay? This will be my last problem for the day, and then we're gonna come back on Tuesday at 3 p.m. my time, or around this time. We're gonna do some integration B. I'm gonna pull some, I hope, are difficult problems. I'm gonna pull some from my book. Maybe I'll do a giveaway of my integral book, but we'll do some integration problems. So Tuesday, be ready for integration, and then Thursday is gonna be like another lesson on specific skills, and then Friday we're just gonna have a party, okay? All right, here we go, guys. So the area was 4/3. Now we're going to take this area and we're going to rotate it about the x-axis. So I know the image is a little weird, but let me just actually let's just redo the whole thing, because we already know the area here. Okay, so we know the function looked like this, and we're rotating this area about the x-axis, and it was from 0 to 4. All right, guys. No shell method. No shell method. Do we use disk or washer? Let me know in the comments. Disk or washer? Or maybe someone could argue that it's the same thing. Airborne says washer. I completely agree. Washer. Jeremiah? Yes. All right. So we're definitely going to use washer. Okay. So what's the washer method? It's the integral from a to b of root x squared minus, and then smaller radius squared dx. You know what's really cool? I was about to tattoo this on my forearm when I was in high school, because it is my favorite equation. I don't know why. I kind of like it. Samantha, I agree. Disk and washer, I mean, washer is like a variation of disk. You're really just subtracting 2 different disks. It's the same fucking thing. Yeah. So if it doesn't touch the axis, it's a washer. Yes, absolutely. Why is it a washer? Because technically what we're doing is, if you look at this rotation, we're trying to rotate this radius that I'm drawing in red, but there's like this space. So when you rotate it, it's going to be like a weird, I guess you can say it almost like a bowl, a cereal bowl. That's actually not even a cereal bowl. It's gonna look like it's gonna have an empty space there. So the way we're gonna find it is we first need to find the larger radius, which is the one that we're going to do there, and then subtract the empty space. So we're going to subtract this in blue. Oh, a cheerleader cone. Oh, shit, yes. I suck at geometry, at like showing how this looks. But yes, a cheerleader cone. If you guys ever seen a cheerleader cone, if you went to a prep rally or even any TV show, you can see what that cheerleader cone looks like, and 100% agree. Gosh, that's exciting. Yes, that's exactly what it would look like. But anyway, that's why we're doing the washer, because we have to get rid of that empty space. All right, so here we go. So we know the parameters is going to be from 0 to 4, but what is the larger radius in this case? Here, I'll write the functions here. I believe it was root x plus 3, and then the other one was 1/2 x plus 3. Okay, so we got to find the larger radius. It's the top function minus the axis. So in this case, it's going to be root x plus 3 minus, I put root 3, root x plus 3 minus the axis, which is 0, and then we're going to square that bad boy, minus, and then now we're going to do the smaller radius. So it's going to be, thank you, Airborne, yes, root function. Now the smaller radius is going to be the 1/2 x plus 3 minus 0, and then we're going to square that bad boy again. If you want to be successful in math, you got to show all your work. Try not to do so much stuff in your head, because you can run into some problems here. But anyway, let's continue, guys. So we have 0 to 4. Let's simplify this a little bit. There's nothing really to simplify. The 3 and the 0 just becomes 3 squared minus, and then we have 1/2 x plus 3, and we're going to square that. Okay. Ooh-wee. I feel... So I'm just going to separate this into two different integrals, because there's like two different methods that we could use. And this is why I believe it was Samantha that said, I think it was, isn't washer the same thing as disk? Yes, because if you look at this, I separated this into two different integrals, right? And it's going to be, and it looks the same. So I just have two different disk method problems. Okay. Guys, what do you guys think? Let's talk about that first integral, okay? So we're going to focus on this one. I'm going to circle it in green. Okay, so what do you guys think I should use? Should I use U substitution, or should I just multiply and FOIL the whole thing out? What do you guys suggest? So let me know, U substitution, or just say U, or FOIL. Okay, Rocker says FOIL. Nick, why do we minus 0? Because we're subtracting the x-axis. Look at the graph real quick. This equation is 0, and that's why I'm subtracting it from 0. If it was the line y is equal to 1, y is equal to -1, then you need to subtract those numbers. Yeah, I agree. As everyone says FOIL, or I see some people saying FOIL, I would not do U sub. So I'm going to FOIL this thing, okay? So then this is going to become pi 0 to 4, and I'm going to FOIL this. So bear with me. This is going to be x plus 6 root x plus 9 dx. Okay, so let me just rewrite this, because I have that radical. I'm going to make it x plus 6 x to the 1/2 plus 9 dx. Let's not worry about the other one. Man, I am your math teacher. We're chilling here. Yes, so whatever you guys want to cover, let me know in the comments. I'll keep note of it. Man, we're here. We're having fun. I'm going to try to, the more support we get, the more times I can go live. I can go live every day if you guys want me to. I'll try. That's not a promise, but I'll try. All right, so let's go ahead and multiply this, or integrate this. This is going to be x squared over 2 plus, check this out, 6x to the 1/2. And this is supposed to be, not 1/2, I'm sorry, to the 3/2. And then this is supposed to be times 2 over 3, but let's simplify that now. So this is just going to be 4 plus 9x, and then from 0 to 4. Okay, Rocker, just have fun with it, man. Sometimes it's just nice to look at math problems and be like, this is a shit. That's it. All right, guys, so when I plug in the 4, let's go ahead and talk about that. Okay, so this is 16 over 2 plus 4, and we talked about this one in the previous problem. Okay? Yes, I agree that 1/2 antiderivative is difficult. You just have to work with those fractions, okay? I kind of did it in my head, but show the work if you need to. When I plugged in the 4, for that second one, is become the square root of 4, which is 2, cube it, that's 8. So we have 4 times 8 plus 36. Okay, let's simplify this. So I have pi 16 over 2, which is 8, plus 32 plus 36. Okay, let's combine that. I feel like I can add these things, but I'm just going to make sure. Okay, that's 76 pi. All right. If you guys found something incorrect, especially Math Nerd and Harry, let me know, okay? But this was the first area. I'm going to make this smaller, and now we're going to talk about the second area, which is the one that we're subtracting. Hold on. I can't shrink this. Guys, what's going on? Okay, hold on. Hold on. Okay. Trying to annotate this. Guys, I can't shrink this. No. No. Okay, well, we're just gonna... What is going on here? I don't know why this can't happen. Okay, Jesus. I'm kind of panicking here, but let's just talk about the blue area. So I'm going to highlight this. We're talking about the blue area here. I didn't mean to do green. I meant to do blue. So let's set it up. I'm going to try to do it here on the right side of the screen since Zoom won't let me shrink this. Thank you, Math Nerd. Yes, everyone keeping me on my toes here. Okay, so here we go. Let's talk about the blue area. So it's this one over here. So this is pi 0 to 4. And I'm going to have to, what do you guys think? Should I FOIL this or use U substitution? Give me a U or give me a FOIL. Captain Credit, this is Calculus AB, I would say. Okay, I'm just going to use, okay, Harry's saying FOIL. If I see another FOIL, I'm going to FOIL it, but I can use U sub, whatever you guys prefer. All right, so let's just try this out. Let's FOIL the whole thing, okay? U sub could have worked as well, but FOIL is going to be fine. So that's what's suggested. Okay, FOIL it is. Here we go. So I'm going to FOIL this. This is 0 to 4. And so when I FOIL this is 1/4 x squared plus 3x plus 9 dx. This is the hard part about it. You just have to know your fractions. Okay, so let's go ahead and integrate this. This is x cubed over 12 plus 3x squared over 2 plus 9x. And then we're doing from 0 to 4. All right, guys, so let's go ahead and plug this in. When I plug in the 4, I'm plugging it into everything. So that becomes 4 cubed, so 64 over 12 plus 3 times 16 over 2 plus 36. Okay, so let me simplify this, guys. I'm trying to be as cautious as I can. I can erase this. I can't make it smaller, which sucks. But luckily for us, this is our last problem. Okay, so 64 over 12. I guess you can divide everything by 4, so that's 16 over 3. Plus, this is 24 plus 36. Okay, so let's go ahead and add those together. So this is 196 over 3 pi. Okay, this could be Calc 2 as well. Yes. Basically, when you take Calc 2, you're taking everything about Calc 1, and then you're going above and beyond. All right, guys, so now my total area. I'm just going to put it up on top in red. Don't forget total, or the volume. I'm sorry, not area. Volume is going to be the larger one, which is 76 pi minus 196 over 3 pi. Okay, so let's just combine this. All right, guys, the answer is 32 over 3 pi. That is a solid. TikTok Tina. So the reason why we squared it was because we were using something called the washer method. And if you look at this equation, okay, I'm going to highlight it in blue. Well, let's highlight it in red. This equation here, okay, you have to square these. I'm going to highlight that. Okay, so it's a lot of stuff. I mean, there's a whole reason for it. But, guys, this is the volume of the solid revolved about the x-axis. All right. And that does it for today, unfortunately. Stick around, guys. Follow along. I'm on TikTok. I'm on Instagram. I'm on YouTube. I try to post as much as I can. Next Tuesday, around this time, we are going to do an integration B. I'm going to find as many problems as I can. Hopefully, you guys can follow along and grab a piece of paper, a pencil, and we will do some math then. All right. hopefully you guys have some fun plans this weekend. I'm probably gonna go like skiing, maybe some snowshoeing. It's raining out here, and it's also snowing up in the mountains, so that would be fun. Any weekend plans for you guys? Anyone doing anything? Let me know what you guys are thinking of doing this weekend. It's a 3-day weekend, or technically a 4-day weekend for some people. All right, cool. My mom. Okay. All right. Well, nah, I wouldn't even tell you anything about what happened, but it's all right. I feel you. All right, guys. Anyway, hope you guys like this live. I will see you guys Tuesday, same time. Integration B. Let's do this. Take it easy. Bye.